These are some of our objectives: successfully substitute values into algebraic expressions, to match correct statements to algebraic statements, be able to tabulate values. The lesson objective today was students had to successfully substitute numbers into expressions. They had to be competent in understanding the English equivalent in terms of statements to the algebraic expressions. Also to be able to tabulate values and substitute expressions, and also have a better appreciation generally of the kind of questions they will be asked in their exams. 10 quick multiple choice questions. It's going to take 5 minutes. All I want you to do is write down the answer for me. Question 1. So we had 10 questions about algebraic substitution, and the first 3 or 4 were quite simple. Then it became brackets, then it became square numbers. It's just an initial assessment for me to understand the pace of the lesson. I might think they all know this. Unless we do that initial check, it's very difficult to determine the pace of the lesson. What does 2a mean?
I think it's times, so 2 times 5.
Okay, so this 2a is 2 times a, yeah? So what's the answer? C. Okay, question 1. What's the quickest way to find the answer to that question?
Do the brackets first.
Do the brackets first. How did you know to do the brackets first, Shazna?
BIDMAS.
BIDMAS. What is BIDMAS?
Basically, it's a structure sort of thing that.
To my pleasant surprise, they still remembered some of the things that they did at GCSE level. Most of the class know most of the questions. Quite a few of them got 10, which I was really happy about. So that tells me, all right, these students are quite comfortable. Let's take it to the next level. You know, I wouldn't have asked decimal questions and odd numbers and even numbers if I didn't think the initial assessment, proved to be favouring them, if you like, in terms of the good assessment. I want you to arrange yourselves. The next part of the lesson was to ask students to stand up and give them a card and substitute n equals 1. They had to arrange themselves, but the algebraic expression is the smallest to the largest.
Mine is, what is mine? Mine is 3 times 1 squared.
Which is 3. 3 squared is 9. So you have to go through.
Well, I like the bigger cards because it made the class come together and work as a team. Because most people are shy. And
it's more interactive.
Yeah, it's more interactive, yeah.
and it was kind of hard as well. But then if it's hard, you just go to a person and they just help you, help you around with the answers.
The whole class was working as a team.
Why did you get -1? Some of my students, they still struggle with negative numbers, fractions, powers, BIDMAS, these are all constant challenges that we face.
Got 1 and power to 0, so that's 1. Yeah.
Okay, so do you believe anything to the power of 0 is 1?
Yeah.
Yeah?
Yeah.
Open the envelopes, please. You should see 4 colours, okay? Green, pink, blue, and yellow. Okay, I allocated an envelope to every student, and there were 4 different colours. The students had to get the pink colours, arrange them so that n is equal to 1, and make the biggest value at the top of the table and the lowest value at the bottom. So they're more comfortable with it because we did that class activity. I think if they didn't have a bit of practice initially, then they would have struggled a bit more.
For 1, so that's a half. A half plus 3, which is 3.5, isn't it? 3.5. 3.5.
Plus 6 is 1 plus 6 is 7. 7 divided by 2 is 7 divided.
If their initial assessment was less than 5, then I would have done a couple of examples on the board. It's a very fragile balance with the GCSE students in the sense that if you're too helpful, then the students just bank on your help and they'll just wait until you give them the answer. But at the same time, if you're giving them such hard work, then it's very difficult for them to be motivated. So work should be achievable, but not easily, if that makes sense.
3n, then n2 plus.
Some of them were a bit hard because they gave decimal answers and fractions answers. So yeah, they may look easy, but
Like these were easier, but then with the fractions, I found it harder because I find fractions harder.
A lot of students, even now, they don't appreciate that divided by 2 means half. So they don't realize that divided by 2 is half, divided by 3 means a third, divided by 4 means a quarter. So still, this niggling understanding of fraction is not there yet. Brackets was actually okay because they kept referring to BRIDMAS, so I assumed this would be a problem, but I was wrong, so I'm quite happy that I was wrong. This, they don't like long numbers.
The longer ones. It makes you think a bit more, because it might look a bit simple, but then you have to think about BIDMAS. Do you apply it to this, or don't you apply it, and stuff like that.
Anything more than 2 expressions or 2 terms, they just turn off. So I was quite happy actually that they confidently put this at the
So
top.
anyway, we'll be the highest. Wait, 13, that's 49, isn't it?
Yeah, that's 49.
No, we're working in a team.
We discuss answers and which one is correct and which one.
And if I was struggling, she would help me because I struggled more than she did.
So same with me. So we'll do the orders, and if we're confident in it and we're sure, then we just check with them if they have the right ones, and if they don't, then if we both have the wrong one, then we try to work it out together.
They were talking to themselves and helping, they were talking to each other, and that was really nice, so I could take a bit of a backseat in facilitating the discussion. When you substituted n equals 1, what value did you get?
40 something.
49, I think.
One question. This is 49 and that is 49, you said, yeah? Why do you think both of them have the same value? Yeah.
That's expanded.
Which one?
Yeah, that one's expanded. That one's what's that word? Just give me the word. Factorized.
Excellent, well done. They're the same expression. The only difference is this one's a factorized form of that, isn't it? They will have the same values whichever number you substitute for n. I want you to look at, there's another couple of pairs in there, yeah, that have the same expression but written differently.
He was just advising us
He'll
here
make you
and there.
think. He wouldn't give you the answer like, oh yeah. So let's say there was the answer that was to do with maybe a minus answer or a positive answer. So he'll be like, what does a minus and a minus make? So, he wouldn't give you the answer straight away.
I'm more of a facilitator to allow students to think for themselves even if they get it wrong. So for me, it's a very delicate balance between facilitating students working independently or in pairs or in a group, but at the same time encouraging them, giving them an enthusiasm for maths and allowing and creating a culture where it's okay to be wrong. So that's my biggest sort of objective. It's okay to be wrong, no problem, let's explore. Which other pairs are factorized forms?
N divided by 2 plus 6 and n plus 6 divided by 2.
Okay, so you believe these are the same? When n is 1, what is the expression evaluated to? Can someone help us? I think you have to have a nice relationship with the student so that they can share their ideas with you. I mean, for someone to not be very confident in maths and for them to share an idea which they don't think is right. So I think trust and a good relationship allows students to comfortably comment on their correct or incorrect answers. N is 1. 1 plus 6 is how much? 7. 7 over 2 is how much? 3.5. So are they the same?
No.
Look at your yellow ones. You have to match the written statement to the algebraic expression.
Divide n by 2, then add 6. So look for it here. Look for this here.
Square n, which is
Here, I'll finish here. Look, yeah, see?
n squared
Look,
times
divide n by 2. No.
All right, so let's look at this one. So how would you write that algebraically in your book? Nice. Now, in algebra, do we have the number first or the letter first?
It's this one.
Yeah. Why do you think that is the same with that? 9 times n squared, which is?
I enjoyed this one. It helped me with my English a bit more and understanding, letters and numbers.
With me, I think I found numbers harder. So when I got the yellow one, it was kind of easy. So I just match it up because I've got better English than maths. So that's why I found it useful.
If you have an expression 2n plus 1, okay? We had these cards and these were tabulating the values, and I suspected some students would find it difficult. So I took a couple of minutes out on the board, explain it to the rest of the class, and then sort of let them get along with it.
The first one has to equal to 8.
8.
Yeah. 2 times 1, 2. 2 and 6, 8. Yeah, but the answer for this one is 6.5.
I saw 8 somewhere.
Which one
There
equals
was
to
8.
8? No. But the first one has to equal
6.5.
to 8.
No, that will be 6. It's this one. Yeah.
Okay, wait.
So 1 divided by 2. Half. 6 plus half is 6.5.
Yeah, this one goes.
I think for me it was a little bit harder with these ones because it need to think
Much
about
slower
it.
for you to do. than the other
These ones, yeah.
This one, as I said, because there's decimals, and students usually don't like decimals and fractions. So they would probably ask, how is it possible that you can get a decimal, then a whole number, then a decimal, then a whole number? Why does that work? So we alluded to odd numbers, and there's a half somewhere, and a half represents 0.5. So they had to have a wider appreciation of the relationship between fractions and decimals, because they had fractions here, you see, whereas these are decimals. So then that means you have to have a prior understanding of a half meaning 0.5. So I suspected they'd find that a bit difficult. Here, a lot of these values are missing, so they would just look at that, and some of them would probably do that last because they haven't helped you as much as the other ones. At least here, all the values are given, even though some of them are decimals. Here, nothing is given, or one of the values is given. And here, 81 and 100, they're square numbers. So that's a leap of sort of understanding as well. And some of them might be unsure to say, okay, well, 1 plus 6 squared is 49. 2 plus 6 is 8 squared is 64. And then 3 plus 6, 9 squared, so is 81. 4 plus 6 is 10 squared is 100. So this matches correctly with this, but our student for n equals 1 wrote 64. So you can tell they've got it wrong.
8. Here, look.
What's 2 times 2?
Isn't it? Do the brackets, look. 1,
Plus 3, yeah.
4. Yeah. It's 8.
How is that 8? Wait, I don't even get it myself. Are you sure?
Yeah. Oh, yo, you man. This one's 8, innit?
Hold on. Yeah, you see.
It's 8, she told you.
Right.
Yeah, but there's another 8s on the other groups as well.
No, there ain't.
Yeah.
There's not.
Go to T6. Where's that? Look, try on that.
There's no 8 there, mate.
Yeah, but you have to fill it in.
You have to fill in. That's 8 anyway. 8, 10, 12, 14. So that one's 8. So if you put replace 1 with n. So 1 add 3 is 4. Then 2 times 4 is 8. And there should be 8 there, but that missed out. So if you do it on this one, so 2 add 3 is 5. So 5 times 2 is 10.
Oh, yeah.
I chose these tasks because they're colourful, they're quite sort of student friendly. It creates discussion, just the fact that they can move things around, and also these are really, really powerful in the sense that you can just walk around the classroom and see that's matched with that. Whereas if you see someone writing and question 58x is 12 or something, it's much more difficult visually to assess someone's work.
Working with cards is more interactive and more fun, and just makes the lesson more enjoyable.
If you are speaking with your classmates and discussing everything, it's more interesting.
Yeah, I found it fun and interactive because if the teacher's like just doing board work and making us write, not everyone's doing the work. And if it's like this, it's like making sure everyone does something because everyone has to be part of a team. And that was good.
My best advice to people that want to use this task, for instance, would be go at the pace of your students. So if some students find 10 of these tabs difficult, do 5. If some of them want to spend 15 minutes instead of me spending 6 minutes, no problem, let them do it. But it's all about flexibility and knowing your students and knowing what works. This is the last exercise, 4 minutes, 4 questions. If A equals 1, B equals 3, which value does the expression equate to? Raise your green if you think it's 9, yellow if you think it's 12, and red for 6. I asked 4 questions at the end. most of them got it correct, and I think 2 or 3 of them, all of them got correct. So that tells me they understood something there. And they even explained you factorize this and you expand that. So they're using mathematical language and they're getting their questions right. So I know that they know. This is the last one. Which area do you think the picture represents? I ran out of time, but that was through a lot of questioning, and I didn't really have time for this. That's why the last question of the preliminary, they said, what's this? But if I had a bit more time, I would have given them the geometric equivalent. You know, I didn't mind sacrificing the last part of the lesson in order to just engage their minds and sort of interrogate and scrutinize their thought process, which hopefully came through in the lesson. If I had time in the lesson, this extension sheet was aimed at giving students a better understanding of the algebra that students learnt this lesson with the geometry that we've learnt previously as well. They know perimeter is where you add the outer edges of a shape, but some of them might be a bit unfamiliar with the side lengths being algebraic expressions. And then the hardest question is where actually some values are missing, and they're not just numbers that are missing, they're algebraic expressions that are missing. So, you know, this requires a lot more sort of thought, because not only do you have to work out the side that's missing, but you have to work out the algebraic side that's missing. So there is differentiation that aims to sort of test the students the more they progress through the worksheet.